Welcome back to Wickerson Studios. Michael Wickerson here. I wrote the script yesterday and I'm pretty happy with it. I'm happy with kind of how much I've kind of debugged it and worked with it. And I was asked to do a project like looking at these surfaces. How could they be milled, not just X and Y axis? They could be milled with a little bit of depth or actually have a sense of a bubble or some type of surface point been added to it, raised or lowered or shaped. And there's a bunch of little things you can do in here to make this more concave and convex. Get it up like this and then lower that height. Probably have to just take that edit down to 0. I'll just leave it at 1 because it's a multiplier, and bring that back down so I get a little more of a height map on there from what was there, flattening and raising it. So that's what I wanted to do and treat this, but I wanted something that would input anything, like not just like something that's prescribed from polynomial and then put through a rebuild. Let's take a look at something that could be as simple as drawing out a polyline or NURBS curve, whatever you want. Put that in there, and then you should be able to input that in, and then you get this kind of raised surface that does more for the printer and the thickness of the materials you want, and you get a more interesting shape. Now mind you, my shape is not so interesting here. If I grab this point and I'm not going to move it outside of being planar, but if I change it I can kind of alter that. But the script runs really nice, so I'm going to rebuild it for you. And the test piece that I did was over here. Let me bring this over here and I'll just show a full example of how the script runs. A polygon, a polar array. I've just decided to make it 2. You can make different shapes. You can change the count on that to get different shapes, like say a star, and then you can throw it through a region union, and then if you input that into the shape, that's going to run the entire script. But rebuilding the curve is key. So if I take the rebuild curve and put preview on, you'll see that that actually becomes more organized. That's not necessary for a polyline, but the rebuild curve is necessary in a sense that you have to change the degree to 3, and then the count can also make it different shapes and make it wobble and jiggle and do all this weird stuff as well. Grabbing a surface to that afterwards is nice, and then you really push it into 2 different camps. The one is which is to divide it just to get an average length, so I could use a parameter of a total of a distance, say here. Let's say the distance was whatever this is. I've just got a number slider sitting around here, 6. I can change that distance by a multiplier to make a different distance that then will drive the data farther along coming out of this script. So I took that surface, I divided it into segments, I made a script that is a untrimmed surface, and then with that centroid I said from that centroid to the centroid of the object, depending on the distance, if I subtracted it and multiplied it, I could get a z-vector to actually produce this kind of raised surface from that point in the middle. And then a surface from points is created, and I do a quick scaling up, so when I project I don't miss any of the object, and I project that original shape, the curves to that, I'll project that onto that top surface and nothing gets cut off, and then from that split the surface, keep the 1/2 that I want, and the bottom half I've just lofted between that top curve and that bottom curve. And then pulling them all together, you get a really nice shape. I think this is a great script, so I'm going to build it from scratch and show you how to do it. Otherwise, you can just grab it on the GitHub. I think this is one that's in the private one, and I noticed bifocals, whenever you get rid of one bifocals, you have to get rid of them all and then put them back on. This is a nice little script. I think I'll build it for us. So let's just start from scratch and do the same thing. So we'll take that whole wonderful script that works with any curves, and we will disable it. And we'll go hard into here and say, how do we build this script? So what would I start with? And I'm not going to look at that script. I'm going to look at another example. Any curve will do, so we can just start with that. Let's go down to parameters and grab a geometry. And then let's make a geometry, and we can play off the size and take that. And I think this is really a nice tight script. Let's input that geometry here, set one geometry, and we don't really need this right now, so we can hide it. The first thing I like to do to any curve coming in, because those curves have different control points on them, I like to use the rebuild curve just to handle later making nice surfaces. And because that's a polyline, or it's not a polyline, but it could very well be a polyline if I was to go in and create something like a primitive polygon, that's not going to work farther in my script if this degree is still not defined. You're going to have a polyline curve. So what I want to do is move to just having a curve, and you can do that through just ensuring anything you make is treated as a degree 3. You want to do that. And then also for the rebuild count, you want something substantial. So I usually type in 12 as a number slider to get myself up to 100. And then I've got a really nice rebuilt curve. From this curve to this curve are totally different animals. And that's a little subtlety that most people miss. But in Grasshopper and computationally working, that planar curve, periodic planar curve, and then this one is a periodic planar curve. And there's quite a difference in that, and that's why you have to do that. So now you can move on with your script in two directions. I'm actually going to take that script and divide that curve. So go in, choose my division. I'm going to divide my curve. I'm going to hard code in my count, \2, and I'm going to make sure that I only have 2 points coming out of this curve. And those are on. That's going to give me a certain type of distance. And I'm going to use this data later on. For those 2 points, if I want to bring them together, I could do that through a certain dispatch, which I love as a node. And then from that node, I can build my distance and find out a number. And then that number can actually be controlled to fit the scale of what I've actually made and what I need to ramp up. So I'm going to throw a little bit of math on here with multiplication. And I'm going to have a number slider from 0.01 to 2.33. That's just big, but that'll give me a way to amp this up, and I'm going to just set it around 1.6. So it's going to keep the number pretty basically the same. Now that's ready to do something, but up here, and I probably need to pull this down so I don't want to be looking at that top script to confound us. That top script, I want to do something with that curve that's coming out here as well. So let's jump back into that. I'm going to pull it out in many, many ways. The first thing I'm going to do is do a surface utility isotrim. And you can take that surface, which was the original, that curve is closed. I definitely have to make that surface first. So that surface is then going to be passed in as my surface, as an isotrim. And then in the math tabs, there's this wonderful domain tool, divide domain to, and I'm also going to put in the surface as that domain, and I'm going to set that count to something I can handle, and I'll set it to 12 and bring it down here so I can subdivide that surface, and I end up getting this wonderful subdivision that's bigger than that original shape that was coming in. Now sadly, this curve has been registered. That's the curve I'm dealing with. I'll get rid of this one. 1 second.